Hi, this is Shyamala Gauri, Assistant Professor in Rohini College of Engineering and Technology. Subject code CS3401. Subject name Algorithms. Unit 2 Graph Algorithms. The topic to be presented here is Dijkstra's algorithm. Definition: the Dijkstra algorithm finds the shortest path from a particular node called the source node to every other node in a connected graph. It produces a shortest path tree with the source node as the root. It is profoundly used in computer networks to generate optimal routes with the aim of minimizing routing cost. In Dijkstra algorithm, the input is a graph representing the network and a source node S. Output is a shortest path tree SPT of with S as the root node. The following elements should be initialized: an array of distances, dist of size v, v is number of nodes, where dist of s is equal to 0 and dist of u is equal to infinite, where u represents a node in the graph except s. An array Q containing all nodes in the graph. When the algorithm runs into completion, Q will become empty. An empty set S to which the visited nodes will be added. When the algorithm runs into completion, S will contain all the nodes in the graph. Repeat the algorithm while Q is not empty. Remove from Q the node U having the smallest dist of U and which is not in S. In the first run, dist of S is removed. Add U to S, marking U as visited. For each node V which is adjacent to U, update dist of V as if dist of u plus weight of h u minus v is less than dist of v, then update dist of v is equal to dist of u plus weight of h u minus v. The array dist contains the shortest path from S to every other node. The working of the algorithm can be best understood using an example. Consider the following graph having nodes marked from A to G connected by weighted edges as follows. The initializations will be as follows. Dist of 7 is equal to 0 and all other nodes are infinite. Q is equal to A, B, C, D, E, F, G and S is equal to 0. In pass 1, we choose node A from Q since it has the lowest dist value of 0 and put it in S. The neighboring nodes of A are B and C. We update dist values corresponding to B and C according to the algorithm. So the values of the data structures become dist of 7 is equal to 0, 5, 6 and all other distance to nodes are infinite. Q is equal to B, C, D, E, F, G. S is equal to A. The distances and shortest path after this pass are shown in the following graph. The green node denotes the node already added to S. In pass 2, we choose node B from Q since it has the lowest dist value of 5 and put it in S. The neighboring nodes of B are C, D and E. We update dist values corresponding to C, D and E according to the algorithm. So the values of the data structures become dist of 7 is equal to 0, 5, 6, 12, 13, infinite, infinity. Q is equal to C, D, E, F, G. S is equal to A, comma B. The distances and shortest path after this pass are shown in the diagram. In pass 3, we choose node C from Q since it has the lowest dist value of 6 and put it in S. The neighboring nodes of C are D and F. We update dist values corresponding to D and F. So the values of the data structures become dist of 7 is equal to 0, 5, 6, 8, 13, 10, infinity. Q is equal to D, E, F, G. S is equal to A, B, C. The distances and shortest path after this pass are shown in the diagram. In pass 4, we choose node D from Q since it has the lowest dist value of 8 and put it in S. The neighboring nodes of D are E, F and G. We update dist values corresponding to E, F and G. So the values of the data structure become dist of 7 is equal to 0, 5, 6, 8, 10, 10, 18. Q is equal to E, F, G. S is equal to A, B, C, D. The distances and shortest paths after this pass are shown in the diagram. In pass 5, we can choose either node E or node F from Q since both of them have the lowest dist value of 10. We select any one of them, say E, and put it in S. The neighboring nodes of D is G. We update dist values corresponding to G. So the values of the data structures become dist of 7 is equal to 0, 5, 6, 8, 10, 10, 13. Q is equal to FG. S is equal to A, B, C, D, E. The distances and shortest paths after this pass are shown in the figure. In pass 6, we choose node F from Q since it has the lowest dist value of 10 and put it in S. The neighboring nodes of F is G. The dist value corresponding to G is less than that through F, so it remains same. The values of the data structures become dist of 7 is equal to 0, 5, 6, 8, 10, 10, 13. Q is equal to G. S is equal to A, B, C, D, E, F. The distances and shortest paths after this pass are shown in the figure. In pass 7, there is just one node in Q. We remove it from Q and put it in S. The dist array needs no change. Now Q becomes empty. S contains all the nodes and so we come to the end of the algorithm. We eliminate all the edges or roots that are not in the path of any root. So the shortest path tree from source node A to all other nodes are as follows. Thank you.